Welcome. You're about to listen to a presentation by Şafak Arslantürkoğlu, founder of Leo Consulting. The presentation of Şafak was part of the program of the 5th panel organized by Çare, as part of the panel series Turkey and Syria after the earthquakes. Şafak Arslantürkoğlu is a postdoctoral researcher at ETH Zurich and the founder of Leo Consulting, a firm dedicated to the assessment of existing structures. Through Leo Consulting, he actively contributes to advancing structural safety and resilience, effectively bridging the gap between academic research and practical applications in the field. He received his PhD in earthquake engineering at ETH Zurich, concentrating on seismic assessment, particularly for unreinforced masonry structures. His research emphasized codified assessment procedures and innovative methods, addressing seismic risk and its mitigation in seismically active regions with a specific emphasis on life safety considerations. Şafak has a degree in structural engineering from the Karlsruhe Institute of Technology in Germany. Following graduation, he worked with Bayatçı Partner Consulting in Switzerland to assess and retrofit diverse structures with a focus on seismic and punching shear safety.
All right, thank you. So let me start. First, huge thanks to Kare for the invitation. I'm delighted to have this opportunity to present at this event. And I am a postdoctoral researcher at ETH Zurich, and in parallel with Leo Consulting, I'm working in the area of seismic and structural assessment, as well as retrofit of existing buildings. So to start with, I would like to give you a short introduction into the area or into my area of interest, both in research or also for the professional career. So I'm focusing on regions with varying degrees of seismic activity within Europe, where unreinforced masonry buildings represent a significant portion of the existing infrastructure, especially here in Switzerland. So what I'm doing is my research focuses primarily on enhancing the safety of code-compliant buildings. I try to evaluate the reliability of structural codes and also working with methods for the quantification of uncertainty in seismic risk assessment. So the Hatay Planning Center report provides valuable insights, so huge thanks to the contributors. It has valuable insights into the effective post-earthquake recovery strategies. But given the length of the report and the time constraints of this presentation, here I try to extract some of the actions from the report that align with the focus areas of my work, and I will try to respond with an emphasis on these topics. So previous speakers already mentioned, dear professors, the microzonation studies. So I will skip this. Also, Professor Taşkın mentioned the need for the definition of site-specific response spectra with appropriately defined corner periods, etc. So what I'm going to be speaking about is I will try to focus on two things in response to action M8 and action M2 and 7. First, the cultural heritage status of buildings in Antakya. What I'm going to do is I will try to focus on this topic from an engineering point of view. Then I will try to speak about the pre- and post-earthquake assessment of this building. So these cultural heritage buildings, they are primarily consisted of unreinforced masonry type. So that will be my main topic. And to finish my presentation, I will also like to focus on the structural codes and regulations. And I will try to address whether there is a need to differentiate between the regulations in terms of the assessment of existing structures and for the design of new ones. So to start with, I would like to first introduce you the existing building stock of Turkey. You can see here clearly that reinforced concrete is dominating, especially after 2000. So when one would look at this picture or at this figure, you may think that unreinforced masonry is not as relevant as RC. But when you look at this red bars before 2000, they were very prevalent in the building stock of Turkey, especially those existing buildings. These also include cultural heritage buildings, but also masonry buildings in rural areas. So when we are looking at typologies, I would like to differentiate between reinforced concrete buildings. That is mainly the focus of the Turkish code. So I want to differentiate between reinforced concrete and unreinforced masonry buildings. When we have reinforced concrete buildings, we have different sets of failure pictures. Can be a banding failure, shear failure, or a combination of both. But the distinct feature of reinforced concrete buildings is the so-called box behavior. So in these buildings, we have usually reinforced concrete slabs. These slabs tie the walls together, meaning the building is able to generate a global response. In this case, usually the structural elements are responding to the excitation in their in-plane response. However, when we look at unreinforced masonry buildings, there we have a huge challenge due to this out-of-plane behavior, especially those with timber floor diaphragms. They are not in this case, the building is not capable of deliver or response to the earthquake in a global manner. And what happens is usually is that we have detached walls or loss of connections, which can cause, which did cause actually also in Hatay during the series of Hatay earthquakes, Turkey earthquakes, which caused to substantial losses or partial or total collapses. So the main difference is in plane behavior, we are dealing mainly with material-related issues or challenges. Here in the out-of-plane response, it's mainly a stability issue. So when we now look at closer at how these buildings would behave or how this behavior would look like, here I have the same example. We can clearly see the separation of the facade wall. What we can also see is the modernization of the floor system here, but however, it was not enough to restrain the facade wall from failing. So in this case, again, we are dealing with stability, with a stability problem, meaning we are just only requiring the stability of the dynamic nature of this phenomenon. And for this, this phenomenon, these local failure modes are considered only in a couple of codes worldwide. One of them being the Italian code, and here this Italian guideline. So my proposal would be to include this type of behavior also in the Turkish code regulations, because we already have available tools that we can use for assessing this type of behavior. So then I'm coming to my second part, whether we should apply different criteria for the design of new buildings versus the assessment of existing buildings. So here you're seeing the results of a survey. So a group of researchers and engineers were asked whether we should use different criteria. The majority of the engineers share the opinion of we can relax the performance objectives because the seismic retrofit is generally much more expensive than the seismic design. However, on the other hand, the majority of researchers have the idea of there's no need to define different criteria as long as we take the remaining lifespan into consideration. So what I want to say is here, I would like to point out with this example. So the relaxation of performance objectives should not mean that we should accept a higher risk in existing buildings. So in the ideal situation, we should aim for the equivalent risks in new and existing buildings. And I want to show you how. So the risk is the combination of the seismic hazard and the vulnerability of the building. The hazard denoting the likelihood that the building will experience an earthquake during its lifetime, and the vulnerability representing the degree of loss when this earthquake would hit this building. So when we have a new building with appropriate seismic design, it would have a low vulnerability, and this hypothetical building will have a long lifespan because it's a new building, and that value is, or lifetime is set usually to 50 and 100 years. So when we want to achieve a uniform risk with an existing building, we can follow two approaches aligned with the last slide. We know that this building has a shorter lifespan. That means it has a lower likelihood to be hit by an earthquake. And hence, when we want to equalize risks, we can tolerate a higher vulnerability only if we can limit the lifespan to a short period. Or what we can do, we can dictate a retrofit. This also concerns the buildings in Hatay or in other seismically active regions. We can dictate a retrofit to reach a low vulnerability if the building is desired to remain in use for a longer period. So to conclude, I want to sum up my points in unreinforced masonry buildings, particularly those with flexible floors. A global model would be only as accurate as the accuracy of its weakest link, and that weakest link is usually the out-of-plane behavior of masonry walls, which would avoid the building to generate a global response. So hence, when we make the implicit assumption, and this assumption is very common in practice, so when we assume the structural integrity, we are automatically underestimating the collapse risk of the building. So what we can do here is there are many tools to evaluate this behavior that can be also implemented into the Turkish codes. I'm sorry, I still had, just give me one more second. And then last couple of words regarding the Turkish Building Code 2018. The code is very comprehensive for existing buildings. However, it can be challenging to reach the safety targets as new buildings. So as a result, what may happen is that residents or landlords often denying an assessment due to the potential need for a demolition of their building or retrofit, which would require their relocation. So when we consider that Turkey is hit by a major earthquake every couple of years, on average, we may have not enough time to retrofit and rebuild every single buildings in these regions. Hence, what we can do is we can focus on studies to prioritize buildings. For instance, for buildings with high vulnerability, there we need immediate action. And here we can perhaps shift our focus to preventing collapses with practical regulations, also with easy to implement regulations. So that brings me to the end of my presentation, and thank you very much for listening.